Okay, so let's do some examples. And again, in these cases, like we did before, we're going to be setting up the hypothesis test. And then we're going to use a given p-value to make our decision, and then we're going to interpret it. So we're skipping the part about the actual calculations. And again, I'm going to show you soon using SPSS how we can do that. So that will fill in that aspect of it. But we need to be able to do all this other stuff that really the computer or the technology doesn't do. We have to be able to make these, set it up, make decisions, and interpret the decision. All right, so we've been given that a claim that the mean difference is greater than 0, the significance level, and some data about the sample statistics. Okay, so let's go and set up our hypothesis test. All right, so we were given that mu d is greater than 0. Again, that has to be the alternative because it doesn't have the equals. So the null hypothesis would be mu d less than or equal to 0. This has been given as the claim. If we look to the alternative here, we see that mu d greater than 0 tells us this would be a right-tailed, so one of the one-tailed versions. Okay, so then what we would be doing, we would be using all this information here, getting us to t, which would get us to a p-value. All right, so let's say that's been taken care of, and we end up with a p-value of 0.0586. All right, 0.0586 is our p-value. Just like any time before, we compare that to our alpha, 0.05. We do see that this p is bigger than 0.05. So with a p-value bigger than alpha, we fail to reject H0. Okay, now to interpret that decision, we go back and we say, okay, well, the claim was in the alternative. So this is a support mode problem. So we either had enough evidence to support the claim or we didn't have enough evidence to support the claim. Again, we failed to reject H0, so we were not able to make it to the claim. So there is not enough evidence at 5% significance level to support the claim that mu d is greater than 0. There we go. Not enough evidence to support the claim. Okay, let's take a look at another. This time the claim is the mean difference is 0, 10% significance. There's our data. So let's set it up. All right, so the mu d equals to 0 must be our null hypothesis. On mu d not equals to 0 is our alternative. This one is the claim, the null, and because we have the equals not equals situation, this is two-tailed. All right, so again, we would take all this information here, get our t, have that give us our p, and let's say that p is 0.3077. There's your p. You compare that to your alpha of 0.10. Okay, 0.3077. That is bigger than 0.10. Again, fail to reject H naught. Okay, so let's interpret that decision. Let's go back. The claim here was in H naught. So this is a rejection mode. So either we had enough evidence to reject the claim, or we didn't have enough evidence to reject the claim. Because we failed to reject H naught, the claim, then it means that there is not enough evidence at 10% significance level to reject the claim that mu d equals 0. There we go. So let's look at another example here. This is a better one. This is actually has the data for us to see, so we get a better idea what this is really looking like. So a scientist claims that pneumonia causes weight loss in mice. The table shows the weights in grams of 6 mice before the infection and after, and 2 days after. At alpha equals 0.01, 1%, is there enough evidence to support the scientist's claim? Assume the samples are random independent and the population normally distributed. Okay, so there's our before and after. Again, very common with dependent samples here. Scientist claims the pneumonia causes weight loss in mice. All right, so if we're talking weight loss, again, we're going to be doing before minus after. Okay, that's going to be, our value from before to our value after. So before minus after. If there's weight loss, then after would be smaller. Okay, so we're going to have a bigger number minus a smaller number. That means our difference would be greater than 0. Well, that's what's being claimed. Okay, so let's set this up. And mu d greater than 0 without the equals is alternative. Mu d less than or equal to 0. This was our claim. With mu d greater than 0, this would be right-tailed. All right, so again, we'd have to put all this data in and get us to our t-value, get it to a p-value, and let's say we had this p-value of 0.102. So 0.102 is our p-value. The alpha of 0.01, oh, this is definitely bigger. And once again, we fail to reject H naught. Okay. So let's see what was going on here for our interpretation. Well, it was the alternative, that was the claim. That's a support mode. So we either had enough evidence to support the claim or we didn't. So again, we failed to reject the null hypothesis, not being able to get us to the claim. So there is not enough evidence at 1% significance level to support the claim of the scientist. Of weight loss. Okay. So there again, so we've been able to see the structure of these problems of how, depending on whether you have an independent or dependent sample, they take a little bit of a different flair, but the treatment is very much the same. And soon we'll take a look at how this can be done in full using the technology.